interesting questions, right, to try. But I would like to add a few more there. Okay. So, so initially, Satya gave a definition of similarity, which to the extent that what was said, it was not complete definition, right? So, two quadilaterals have corresponding angles same. So, okay, what is the goal? We are trying to come up with a suitable definition of similarity. And in the process, we are giving all this triangle geometry we're investigating. Okay? So anyways, let's come to this thing. We have two corresponding, let me not write anything. We have basically two quadrilaterals. The picture that we had was probably better, right? And that, I mean, that square and rectangle picture is there, good, but that is sort of maybe too simple to get interesting. And actually, it's not too simple. It's actually good enough. So let's actually go there. Actually, in some way, it's a nice example. Yeah. Right. I'll keep both the examples. So we have the square and rectangle, and obviously we know they are not. So their angles are same, but the ratio of sides is not same. We want to see that. We want to see along with these angles being same, what more can we say so that it will ensure that the ratio of sides is same. Look, why is similarity useful? Because it tells you that the ratio of sides are same, right? And obviously ratio of angles is also turns out to be same, and those two things are for triangles, I'm saying, right? And that helps you in calculations. That helps you from, magnify, demagnify, take a thing, translate it. That says congruency, right? And then you change the ratio and fit it somewhere or something, and you do the calculations, right? So, for example, you have this, this, right? So this is some tower, and this is your angle of vision, and this is distance, this is some dummy thing, some pole or something, and all of its height or whatever. Then you can use similarity to find the height. I mean, this is the basis of trigonometry, right? So those things are okay. That works for it. And my point is that we want some other conditions so that we get the ratio of sides is also same. So far, we are not successful. Coming from the angle direction, coming from stipulating that all the angles are same, which is a decent start in a way. We would want the angles to also have the same ratio, okay? Because we feel that, I mean, let me not get so much in it. Let us just say that we want the angles to be same. Okay. Why? Because because then you want other kinds of. It becomes a debate. It becomes a more thoughtful discussion. But point is, this case, you see that these two triangles are not same. This angle is 45, and this is not 45. So what is it? Maybe 30. So just the angle, but the total angles are same. So the angles being same, angles are all 90. All corresponding angles are same for the quadrilateral. And so we had the other picture. We had similar thing. And then we said, okay, just move it a little bit. And one question came from there. And you have to then end up moving this also. Right? So that, this angle remains equal to this angle, and this also remains equal to this. This is equal to this, but then they are not similar in the sense that, I mean, let me not use the word similar anymore. In the sense that the ratio of size is not same, and because we chop it from slice by whatever, not bisect. It's not bisect. We just dissect. Just dissecting it, then these angles are not same. Right? But what more conditions can we add? Anyone? Some condition that you can add so that it becomes similar, so that the ratio of the sides become the same. Some small addition we can make to this.
Sir, I have a doubt.
Yeah.
Sir, a square and a rectangle can never be similar, right? Because the square has all equal sides.
Right. No, but a rectangle is also a square. So it can be in the, in that special case. Yes. Right. So the ratio of the rectangle of the sides of the rectangle with the sides of the square, the ratio is not a constant. Yes. I mean, the ratio of the corresponding sides this by this is not equal to this by this in general. It's only in a special case of a square. Right? So in that case, it's not the same. So in general, also it's not the same. But what more can we add so that it becomes the same? Okay, here is the thing. What if I tell you that I am dissecting it like this? And what if I tell you that this angle is also same as this? Just that extra bit of information, is that enough to make everything good? Is that enough to make all the sides have the same ratio? Just think. Suppose I told you that this was like 120. Well, it's not looking like 120, but suppose this is 120, this is 120. This was 45. Suppose I told you that this is also 45. And the whole thing was 90, so then this also becomes 45. You can see that that sets everything in place. It's hardly surprising. Just that extra bit of thing sets everything in place. Right? This becomes 15 and whatever. I forgot what this angle, or this was 98. Everything then becomes same. That other angle also. Do you agree? Right? Hey, that is true. Right? Because that is the only missing piece. Any one more information is enough. Because if you know that this is 45, then you know that these two are 45, then you know what this has to be. It's fixed. But then you know that whole thing. This whole thing, they are equal. So then this remaining thing is also equal. Similarly, so then both the triangles, upper triangles similar, lower triangles similar, everything good. Done. Everything good. Is that correct?
Yes.
Right? So just needed that one extra bit of information. And not surprising. If you look back, you'll probably say this is spending too much time on this. Right? It has to be, should be like that. What is difficult today should become easy tomorrow or day after tomorrow, in the sense. So then we can say that that is the missing piece, right? So we can say all angles or all corresponding angles same, plus, how should I say, one extra angle same? You can write it in many ways. I'll just write that all corresponding angles same plus a one pair, or rather I should say one corresponding pair of triangles similar. Like this upper triangle is similar to this lower triangle. If that is also given, which is the same as saying that that small angle which I added is same, because that is essentially what upper triangles becoming similar means, right? So plus one of the corresponding triangles similar. That implies that the other one is also similar. But the spirit of this is that only one atomic piece of information is needed. Right? You see, if the upper two triangles are similar, the lower two triangles have to be similar. Because then that these angles are decided. And the upper two triangles are similar, that could be by angle given, or we could say that this by this is equal to this by this, then that implies that lower ones are also same. Okay. So the conclusion is that in a in a quadrilateral, all angles being same are not enough, but just one extra piece of information is needed to prove everything. You can see that in the square case, obviously, if I make that 30-45, if I make that 30-45, then everything else just becomes same, right? Alright? This is the thing. From here, two interesting questions come. What about a pentagon and something more which I'll not say, I'll just leave it as a problem. So two problems. So let us say that this ABCD ABCDE, and then you have, I mean, just you can use anything you want and use your own angles and use numbers there. So again, corresponding angles are same. Let's say that that is given. So you mark the angles, you can write numbers there. Corresponding angles are the same. Does that imply the pentagon is similar? Of course not. You already given examples. Quadilaterals, obviously in pentagon. You can just make this lower thing square and this one rectangle. Right, and yes. But then the question is, what extra piece of information is needed? What extra piece of information is needed? So if that is given, plus, let's say I tell you that this ABE is similar to A prime, B prime, E prime. Does that imply that the all the ratio of the sides is same? Corresponding sides? No, right? Because you can still make this square and this rectangle probably, right? And still keep all the angles same. Think about it. So what more information do you need? Okay, right? And you'll see that one more piece of information is needed, right? So when you go to an n-gon, like if you have 100 gon, right? Then with the corresponding angles being same, you need 99, you need, I mean, so 100 minus whatever. So yeah, 100 minus 3. 100 minus 3 more pieces of information. Okay. In the sense that you have to say, okay, I need some angle, some other more angles. So you have to say 97 more things to be same. It could become in other way. Like you say, this particular triangle is equal to this triangle in 100 gon, right? You can make a lot of triangles in 100 gon, right? You can see 98 triangles. So you have to say that 97 of the triangles have to be similar. Then the last triangle will also be similar, and then everything will be good. Probably it's like not very interesting. It's like as you expect, right? So far, it doesn't look interesting. But the point is that there's also more output there. You also get more. Okay. And that will, so this is one, and that is coming in this exercise. So, right. Yeah. So suppose now that you have two quadrilaterals. Okay. Which are similar. So now you know what I mean by similar. Meaning that the angles are same and the ratio of the sides is also same. I want both, otherwise, yeah, so maybe you can write that. Angles are same and ratio of sides. I need both. So again, not only one of them will again not be enough. Okay, you need both. All right, now that is given. So now let us say that I give you the diagonals. Okay? So this diagonal and this diagonal, this diagonal. And, okay? So now suppose that so just note it down. Okay, so suppose that this one is 5, this one is 4, this one is 9. Then I wanted to find this. Okay. See if it is possible and try to find. So the quadilaterals are similar. In this sense, I've told, right, the ratio of the angles are same and the ratio of the sides is same. It seems like it should like this, so we get the more output from those extra of so many conditions we need now, but that extra output you get, you have to use that to find that diagonal. None of the sides are given. Okay, try that. Okay, so all that is good. Let us so this is done. Now we'll come to the original question. So we explored all this new stuff. It's new for me also, so never. Okay, I knew some things, but the exact details is. And then this is interesting. Note these things. And don't worry, just give it a try, spend some time on it, and we will obviously do that next time. Maybe how fast and slow we do depends on how. I mean, I expect that those suppose some of you have seen more geometry, then you should do more and you should tell us, right? So I'll erase this, right? And then we'll just do the original question. So in the original question, as I said, similarity, right? So similarity of rectangles. You see, I want the ratio of the, because the angles are same. But again, that does not by itself tell you that the ratio of the angles is the same, right? But that is what I want in the definition that is there. Okay? So now it's not difficult. So let us say this is x and this is y. You know what I mean by x and y here, right? This is the distinction. This is x and this is also x because that was a square, remember, right? It's x. This is also x and this is y and this is x. Right? Now, similar means what? That the ratio of the sides. So you look at the larger side of the larger rectangle, that's x plus y, and then you look at the smaller side of the larger rectangle. So I've taken that side by that side. Or if you don't like this, you would say, okay, I take the larger side of the larger rectangle, and then I take the larger side of the smaller rectangle, which is, I don't know, which one is larger, x or y? Maybe, is there a way to know that? Yeah, we don't know, right, so far. So let's say that x is larger. That looks like that. So this is the larger side, right, of the larger rectangle, of the smaller rectangle. So the ratio of the corresponding sides, right? So you see there is one rectangle here and there is one rectangle here. If these two are similar, obviously similar, I mean in the sense that A, B, C, D, then this is A and this is A prime and this is B prime and C prime, right? Because obviously, right, this larger has to match with this larger. That is the sense in which they are similar. And it says, yeah, common. Yeah. I mean, again, all that is said in the similarity chapter. If you read, right, there is an ABC similar to ACB, then you have to say the side, the ratio, and that it is just it's a matter of reliability. But either way, so coming to the main thing, x plus 5 by x, okay, is equal to what? Again, just take the other pair of sides there. This is x. The smaller side of the larger rectangle is equal to the smaller side of the smaller rectangle. There are other two sides, but then there's no need to talk about them. They are same, and they are dependent on them. This, what do I want? I want x plus. So what did we want? It was given that x is 1. we wanted x plus y. Find x plus y. Just find y. What is y? You can just find it, right? There's nothing to do. But is this first one again? I'm asking, but I'm just saying that is it clear how I've written this ratio? Write it here in a different picture here. X plus y, x, okay, and in this picture it is y, x, and x, right? This larger one by larger one is equal to smaller one by smaller one. Just like you do for triangles, right? You can even just make a triangle. Say that this triangle is similar to this triangle, right? Right? And x plus y by x is equal to x by y. Right? So this ABD is similar to this. Now just do the calculation and see. It's by no means a difficult question, but it's an interesting question for some reasons. So what is y from here? So I'll assume the quadratic formula, okay? So I expect that you know it. And if you don't know it, then I discuss it with other people or everybody, so I expect to know. And if you don't know it, then tell and practice it from usual NCRT practice, usual stuff. So what will this be? 5 root 5 by 2. Okay. But the more important thing is what is x plus 5? X plus y is 1 plus this. So that is 1 plus root 5 by 2. Is this a familiar number? Think about it. Maybe that's also homework. Okay. This number you would have come across in many other questions also. It keeps coming. So okay. We'll discuss all that next time. So we have we did some unorthodox stuff today, so don't worry. But this kind of things is what will eventually is needed. The originality is needed. But obviously the questions we gave are also yes. All right. This is yeah. And for those who are doing the Sunday class, tomorrow's class is as usual. What is the time? Is it 4 or 4:15? Right. So one class is 4:15 IST. Those who are doing that, and then the other is 9:30. So yeah, a lot of classes, but yeah, just this week maybe. I hope you have done the schoolwork in the break, small break. We don't do too many classes otherwise. So, okay, so then that's it for today. Thank you. Bye.
Yeah, thank you. Bye.
Bye, sir.
Goodbye.